Okay, so welcome to this introductory tutorial for R and R Studio. My name is Sam, and I'm a digital fellow with the Graduate Center Digital Initiatives for the year 2022-23. Um, this tutorial assumes that you already have installed R, both R and R Studio. If you haven't, there's plenty of plenty of run-throughs online if you had to do that. But if you have something that looks like this in front of you, then you're probably in a good position to get started. Now, the user interface that you see in front of you has really four central sections. On the bottom left here, you can see the box that has three tabs: console, terminal, and background jobs. Don't worry about these two. Background jobs it will show you a list of work that's being undertaken if you're doing more than one task at a time. And the terminal here is where you can add commands from the command line. More important here is the tab for the console. Now, the console here is where you can type direct commands into R using the R programming language. Be aware that what you type into here will not be saved. If you type your commands into the console, all of the everything you've written will be deleted when you end the session, which is to say when you quit R Studio. On the right here, we have two boxes which you can adjust here. On the top here, we have our environment. This is very important. The environment, which it currently says is empty, is a list, or it will be a list, of all the objects, pieces of data, and the elements that we're working with. You can think of it as like a bin where all your clips and pieces and files are going to go. For example, if you're familiar with Adobe Premiere, the video editing software package, this would be your media bin. This is where all your data is going to be, that you're working with, is going to be stored for the duration of the session. Underneath, we have a couple of useful tabs here: files, plots, and packages. Files is like a directory browser. You can see here, this is my root directory. There's a couple of folders here. And we have plots here then on the next tab, which will eventually show us our visualizations of the data. And then finally, packages here, R Studio's famous packages. We have a list here of all the extensions that allow us to use R in different ways. So depending on your purpose, you can use R for different things. The two most famous packages are probably Tidyverse and ggplot2. We'll be using them today. But for example, if you're a demographer, you might use the demography package. And there's also many other visualization packages that you can use here. Don't worry if they seem unfamiliar. There's plenty of them, and you don't need to know about them in great detail right now. But also useful here as help. You can type in things that you're not so sure about, and if R has some documentation on a particular package or a particular element or a particular command, you can type it in here and it will offer you the documentation that it has. It's quite useful. So let's get started here. I'll go to the final box on our user interface here, which is our first script. I'll just close this to show you what we've got here. It's like a Word document, and you get started with your first script by opening here, New File, and from this list, you choose the top one, R script. And this is just like opening a Word document. This, unlike the console, will be a record of everything you've typed in, and it can be saved to your computer. So you can type whatever you like, and it will be saved as if it was a record on your computer. Very useful. Not like the console where you close it down and everything gets deleted. The first thing that perhaps you might want to notice here is I've put a little hashtag in front of the text I've written here, which tells R that I am just writing out some text, and it's not supposed to be treated as a function. You're not supposed to do any processes, just display it as basic text, as if it was a Word document, once again, or a text document, for example. If your working environment is a little hard to see, if your screen is a little small, you can do Command, or if you're in a Windows computer, I think it's Control, Command plus and minus, and you can change the size of the text on your display. So that's very useful, particularly working with many, many lines of code, typing a lot of detailed commands. You want to make sure you can see everything clearly, so don't be afraid to make things a little easier for you to look at. So let's do perhaps one of the most important things before you get started coding with R, which is to set your working directory. Now, there's two ways you can do this, and the reason why this is important is because you want to tell R which folder you are going to access your data from. So here's the simple way to do it. You simply go to Session and go to Set Working Directory, and here you can choose Directory, and it'll open up a dialog box here, and we can go here to our folder that we need. I'm going to go here to my Intro to R and set here Workshop Files. Bear in mind, you're setting the folder, not the file. So you've got the button that says Open here because you're selecting Workshop Files, the folder, not this particular document. So we press Open, and here you can see on the bottom right-hand side, under Files, R is now looking into that folder and saying, I see one, apart from the metadata here, we see here a file called Internet Usage regions.csv, and that is our data for today, and I'll make sure that's available online for those watching this video. You might also notice here in the console, here we have the command equivalent of the visual operation that we just did. So this is really the second way that you can set your working directory. And I'll paste it here so that you can see how it works. We'll set the working directory, and I'll paste this here just to show you what's going on. This is our first instruction to R that we've typed out right now. Set WD is an instruction to R to set the working directory. You get open brackets or open parentheses, and inside a pair of quotation marks, double quotation marks, you put the path to your working directory. You use the tilde here to go to the root, and then from the root, you can go into your files, your folders, sorry. You'll notice here that R is very good at managing emojis, which is quite useful if you happen to have emojis in your folder titles. It helps to make things a little easier to navigate. But this is another way to get set up with your working directory. So rather than doing it visually as we just did, you can actually type this out. And the way to execute a command on R is to press Command and then Enter. Or if you're on a Windows computer, I believe it's Control and Enter. So we do Command Enter here. And nothing has changed because we are setting the same working directory as before, but we don't get any error messages. We don't have any problems. The working directory is set. And you can change it throughout your project, but it's recommended stay with one working directory per project. Now, the next thing we want to do is install our packages. We want to make sure the little extensions for RStudio are ready for us to use. So our next command we want to use is here. We type in install.packages, and we don't actually need to fill in the whole instruction here, because as you can see, RStudio is very good at auto-suggesting, auto-completing commands that we want to use. So I can either finish typing, or I can simply click here. The little blue rectangle tells you that it's a function. So we click on it, and now inside, just as we had with set working directory, inside the brackets, you can type which packages you want to install. So here I'm going to type inside the quotation marks, I'm going to put here tidyverse. Now, what R will do is it will search its online repository for the tidyverse package. So if there is a package with the name tidyverse, it will search for it. It will, download it and install it. So let's go here, Command Enter. And we can see in the console, it's downloading from an online repository, rstudio.com, all of the necessary content for this package. It's quite a lot. The console, as you can see, is a useful record of all of the underlying processes that R is undertaking in order to get to where it needs to go, or where you've told it to go. So here you've got everything that it's downloaded. And luckily, thankfully, we have a final message here that says the downloaded binary packages are in, and it gives you the directory here. That's not important for us, but it is useful to know that the process was successful. So let's go ahead and do the same for another package that is called ggplot ggplot2. And ggplot2 is a package that allows us to do really nice quality visualizations. We won't look at that in detail today, but it is worth knowing that these two packages are really useful. ggplot2 for data visualization and tidyverse for data wrangling, to do lots of data organization. So I'll press again, Command Enter, and the process was a little shorter here, but you can see now it was successful. And we can also go to packages here on the bottom right to double check that we have them here, and under ggplot2 we do see in fact that here what you want to do to make sure that it's attached to your working environment is to click the little tick box here, and you can see that it's showed here in the console that it's now attached to a working environment. It's not only downloaded and on our computer, it's also ready to run in our RStudio environment. And I'll do the same here for tidyverse. There we go. You'll notice here some conflicts, but unless we get some serious error messages, that should be fine. Don't worry about that for the moment. So let's do some more functions with R. This time, let's get into some simple math. Simple math, and also we'll do a Boolean operator. So you can, for example, with R, do some very basic math. For example, I can type right out here 3 plus 5. Press Command Enter, and underneath in the console here, you get a result. What it's showing you here is this was the command, and the next line we have a one-line result, which is 8, and that's of course what we need to get from that. You can do multiplication and division. So that's useful. You can also ask R to work on logical operators or Boolean operators. You can, for example, ask R, is 3 absolutely equal to 3? And R will say that yes, that is in fact true. 3 is absolutely equal to 3. You can also ask, is it equal to something else? And R will say, no, that's false. This is useful. You can also ask it if it's equal to non-numerical values like this, and it will also identify for you those two values are not the same. So that's good. At this stage, I think it's also very useful to save. The system default for the way you save this document is fine. Just like as you would with a Word document, you can press OK. So let's save here our R script, intro to R. You can save in your working environment or wherever you like. So now we know it's saved, and that's nice and reassuring for the moment. So let's get into a bit more in depth with data here. The next step we're going to get to here is creating a vector. Now, a vector is very simple. I'm going to write here, you can think of it as a list. That's all it is, like a shopping list or a to-do list. You can simply think of it as a list of items, one after the other. It could be a list of numbers, it could be a list of words, it could be a list of, again, operators like true, false, etc. And so you would do this, the command or the function is a C. And after the C, you put the parenthesis, and then you follow it with your values. I'm going to put 1, 2, 3, 4. So I've typed out here my vector. But if I do this now, R won't have it on record. What I'm going to do here is I'm going to give it a name so that it gets attached to our working environment. So here, I'm going to type out my sequence, little caret, as it's called, and a hyphen, and then my sequence here. What I'm telling R to do, it hasn't processed any functions yet, but when I press Command Enter, what this is an instruction to create a vector whose integers are 1, 2, 3, and 4, and its name is MySequence. And what you will see is when we press Command Enter here, it will get attached here to our working environment. It's going to be our first object in our working environment. So let's go Command Enter, and there we go. So R understands that this vector is called MySequence. It's best to use underscores, by the way, if you're not familiar with this. It's best to avoid using spaces because sometimes that can confuse. It being a programming language, it needs to know if it's a complete object or not, and a space might confuse it to think it's two separate values. It knows that it's a sequence of numbers, NUM, and it has a range of 1 through 4 digits, and the sequence goes 1, 2, 3, 4. That's great. Of course, it doesn't have to. Let's type out a new one here. You can type out as many as you like. But here, my new sequence, we can go again with, for example, 1, 500, 0.1, and 999. And we'll go again here. Another one. You can see again, it's a string of numbers. It has 4 integers. It has 4 values inside it. And we get the list here on the right. Of course, you can also create a mixed vector if you like. We could do, for example, 1, true, 5, 100. Oh, I beg your pardon. We could do yes and true. So here we have a quantitative value, a numerical value, and a Boolean operator. So we can press enter here, and now you'll see this mixed vector is understood by R to be a string of characters with values from 1 through 5, which are 1, yes, 5, 100, and true. So slightly different, and R can tell the difference between a string of numbers and a string of mixed characters. At this stage, one thing that is also useful is if you have, for example, a big list here of objects in your working environment, and you need to take a look at one of them. For example, if we had a sequence that had thousands of integers, thousands of items inside it, you can go to print, and print is a very useful function. It tells R to call up whichever object you like. So here we could put here mixed vector, and again R is very good at calling up objects and functions that it thinks you might be interested in. Our rectangle is purple now because it shows that it's an object in the working environment, not a function. And what we need to do here is press Command Enter. And here in the console, you see that it's called up the necessary components or the necessary elements within that object. Note here that the object doesn't need quotation marks because the object is already within the working environment of R. It already knows it's a familiar object. It doesn't need quote marks. It's ready to be used. And I'll show you the difference right now. We're going to next go to open a separated value file. We're going to open a CSV file, one of those classic Excel files, a really basic format for dealing with data. Extremely common. I would venture to say almost a large amount, possibly even a majority of the data you would work with is going to be in a CSV file, comma separated values. So we're going to go read.csv. This is a function of R that allows the program to open and read comma separated value files. So we'll click on that here. We've got our brackets. Now what I'm going to do here is we see in our files, in our working environment, we have our file, internet usage regions. I'm going to type here, internet usage regions.csv. Here, the title of our file does require quote marks because it's not in our working environment yet. It's actually outside in the directory of our computer, and RStudio is trying to access it using the function read.csv. This is not the same as the mixed vector, which is inside our environment here. Read.csv is used to access documents outside of our working environment. So let's do Command and Enter. And what we get here in the console is a full readout, a full readout of our data here, starting with the total with row 1 for all countries. We have here the columns, region, year, and percentage, and then we go through the full list of all the available regions. Now, this isn't particularly useful for us because, as we know, when we close our RStudio session, this console, the console record gets completely eliminated, gets completely deleted. So what we want to do is go back to one of our old techniques here, where we use the caret and the hyphen to give our object a name and put it in our working environment. So since this is our full data set, this is all the data we're going to work with today, I'm going to type here full data set. That's going to be the name for my object, caret hyphen, and then we do the same again. At this point, if you're feeling like you want to cut a little corner, you can do copy and paste, or if you want to practice typing out your lines of code, you can type it, but it should be identical to what we just typed here. So what we've got here is the name is going to be full data set. The caret and the hyphen tell us what is going to be the source of the data. And the source of the data is going to be a CSV outside of our working environment called Internet Usage Regions.csv. Command Enter. And here, this is interesting now, inside our working environment, we get not a set of values, but what R understands to be data, or you might hear the phrase data frame. R understands this to be a data frame. We get a handy little, what looks like a play pause button, and when you click on it, you can see the variables inside the data set or the data frame. And each of these dollar signs represents an individual variable, the region, the year, and the percentage, just like we saw in the console right at the top here. So it's read it. It seems to have read it successfully. If, for example, you're working with a small data frame, a data set, and you need to clean up the data a bit in Excel first or Google Sheets, that's fine. That's not a problem. Whichever method is easy for you, you should go ahead and do that. If you want to view your data set as you might do in Excel, you can click here on the right-hand side, a little button which looks like a spreadsheet or a table. And in this new tab, we get a nice visually easy to read representation of the data as a nice table. The row numbers, and then all the useful columns. You can also temporarily order these data according to the variable. However, be aware this doesn't change the order itself as we move through it. It's just for visualization purposes. It will always stay in the order that's shown in the first column here, row 1 through 147. Just doing this is just a temporary ordering. It's just a momentary look at how the data could be ordered elsewhere. Otherwise, sorry, but be aware that it will always be according to this first column, 1, 2, 3, 4 here. So we got our full data set, and this is our full and complete data set. We're not going to go with anything else. Let's just take a look at sampling the data. Now, this isn't a particularly large data set, but it is useful to know that if you have a very large data set, you might have thousands of rows or thousands of variables. You might even be working with a matrix. Here, this head function is a great way to get a little sample of the data set you're working with. Again, it's auto-completing as I type in full data set, and you can see here the little logo tells us it's working with a data frame. It knows it's a data frame. Don't choose any of these. These are other functions. We here have full data set. So let's click on that. And what we're doing now is we're asking R to use a function called head, which shows us the first couple of rows of the data frame. So Command Enter, and here we get the first 6 rows of our data frame, just a little sample. And if you want to look at, for example, the other end of the data frame, we can do the same with a function called tail. Very simple. It just does the same thing. Instead of the first 6, we get the final 6 rows. And there we are. A little sample, a little look into the data set, just to check perhaps if you wanted to see what the final row looked like. If you wanted, of course, to see the whole thing, and of course that's a little more risky if you're working with something that has an enormous number of rows or variables. But here it's relatively safe. It's just like 147 rows, so we can do print full data set. And here in the console again is the full readout. All of the data we have available is the whole thing. So that's useful. That's a useful way to sample our data. Now, let's move on to extracting and showing individual variables. This is a really key aspect of R, and it's an extremely important function that you'll want to use going forward. It's not so much a function, I suppose I should say, as a little character which helps you get to the exact variable that you want. What I'm going to do here is if I wanted to extract a particular variable, we've got here region, year, and percentage. Say I wanted to extract all, or I wanted to show, for example, just the column relating to region. I would type here full data set. And then without pressing space or anything else, I put here the $sign. And the $sign here is a very small function used to extract one particular variable. And here you can see already R is having been provided with the $sign, it's already looking into the data frame to see which variables are available. And it's calling up the 3 available variables. We can here either type region like that, or we can click to complete like that. And now, if we press Command and Enter, what R reads out for us in the console is just all of the values inside the region variable here, and we get it as a big long list. This is essentially a list of all the countries in our data frame. And of course, we can do the same for different variables. Let's see, we could do one for the percentage, Command Enter, and here we get a big long list of all of the percentages in our data frame. So very useful. And of course, this hasn't attached anything to our working environment yet. It's essentially going to be forgotten if we were to quit the session now. So let's go to, for example, we can create an object called region list. And then we do caret hyphen full data set. And then we go to region, Command Enter. And here under region list, you'll see we have a vector. It's our new vector. And this is a useful extension now of, as you can see, the original vectors we were starting out with. You can see that we have a vector called region list, which is a list of characters integers 1 through 147. And you can see it starts to list out the beginning of all the different regions. So that's useful. We've attached a list of regions to our working environment. We've extracted one variable from our data set. And as usual, with everything else, you can take a look at the first couple of variables, first couple of entries. Sorry about that. First couple of entries inside our variable called region list. And here we go. We get the first couple of them. Now, our working environment is looking a little busy here. We've got a couple of things that perhaps we won't end up needing to go back to. So if you're interested in removing something from your working environment, what you can do is use RM. And RM is a good way of getting rid of a particular object in your working environment. So if I type here my sequence, it auto-completes, you can press enter and watch in the working environment. You can see it's been deleted. Now it's been deleted forever. It's not coming back. So be careful when you delete these things. That is it now. That has been deleted. Unless, of course, you want to bring it back with the original command. So here we could go back to our original command here to R and actually reinstate it by pressing Command Enter. But of course, you want to make sure that you have all the data available. If this was dependent on some data from outside R, you want to make sure that's all available. One of the useful things about R in this respect is you can iterate these different lines of code as you go through, but you do have to make sure that you have everything in line, otherwise you may run into errors. So I'm going to remove this now, and we'll move forward. So what if we wanted to extract particular values from our data frame more specific than just one column or one variable? So I'm going to put here extract values from a data frame using square brackets. I'm going to put it here in, I think I shall put it in asterisks. Our most important guiding principle for this section, which is row first, then column. And this is going to give us a guide for how to extract particular values. So let's call up the full data set. And instead of using parentheses or curved brackets, I'm going to put here square brackets like that. And inside the square brackets, you put two numbers or two variables. So for example, if I wanted to access the fifth row and the third column, I would type here 5, 3. And what this does now, the comma is extremely important. You're calling up the full data set, our only and most important data set. And within that data set, you want to call up the fifth row, the data that's in the fifth row, and the third column. If I press Command Enter now, you'll see in the console, it has called up an individual value. Now that's really useful, but we're not limited just to individual numbers. What we can also do is put particular ranges in. And this is where it gets particularly useful for extracting data from a data frame. Here, I've put a range of values separated by a colon. And the difference is this one says extract the value of the cell which is in the fifth row and the third column. This instruction tells R to extract the value which is at the fifth row and columns 1 through 3. So if I press Command Enter, what we get here is the fifth row, which includes the region, which for us is the total or all countries area, the year, and the percentage. So we've extracted a full row, which for us happens to include all the 1 through 3 happens to show us the full row. But for example, we could do 1 through 2, and it would only show us the first two columns. But 1 through 3 gives us the full row. Now, again, as we've done before a couple of times now, we can give our variables, we can give parts of this data frame specific names, and we can save them to our working environment. So let's say I want to have all the data from Central Asia data. Caret hyphen, so that's going to be the name of our object, and we're going to tell R to go inside full data set, and then we'll put brackets, square brackets, and we're going to do something a bit different here. But what we're going to do is call up a variable. We're going to call it data within the variable for region, and it's going to be full data set. Again, it's a little confusing, but the reason we have to call it up again is we need to get to region, as it's showing here, and then we use our Boolean operator. We say exactly equal to Central Asia. Why is this going to work? Well, if we go to the full data set, we can see that we do have Central Asia as a variable, as data within our region variable, that we can extract. So what we're doing here is we're telling R to extract all of the rows that have within region the values exactly equal to Central Asia. I'll put a comma here to clarify that we're getting the end of our row call, and then as we get after the comma, it comes to the column call. If you leave it blank, it will automatically return all of the relevant columns. So I'll just go through that once more. Our object in the working environment is called Central Asia data. It's going to take data from the full data set, and within that full data set, any variable relating to region whose name is, or whose content is exactly, or value is exactly equal to Central Asia, and any relevant columns that pertain to this particular row. So Command Enter. And here we get a new little data set, a data frame called Central Asia Data, telling us it's 7 observations of 3 variables. We could read that really as it's saying 7 rows of 3 columns. And if we take a little look at it, the tab comes up. We see here we've extracted the data relating to Central Asia. Our full data set has all the regions. Our new little data set or data frame has just Central Asia. You can also do a little preview here. You can see the variables are the same, but only the ones that relate to Central Asia. And this is the benefit of just leaving this section blank, is it returns all the columns that are relevant to the rows we've identified here. So that's great. And what if we wanted to start visualizing this data? Well, this is the beginning of using ggplot2. So we'll go to set up a plot using ggplot2. I'll put here, remember to install and attach the package, just like we looked at earlier. If you want to, you can go to packages and check that ggplot is still here. And yep, it's the tick also means it's attached to our working environment, just like all these objects are in our working environment as well. So we'll call up the function ggplot, and you can see it's already offering us here. It knows what the function is. It's ready to complete it for us. The brackets come up. And the first thing you want to do when you are setting up a ggplot, when you're setting up a data visualization, is tell R which source of data you are going to use. So what goes in the brackets first is Central Asia data. This is our data source. And then we put a comma. And then what happens next is you type AES, short for aesthetic mappings. And inside these brackets, you tell R which of the 2 variables you are going to map into R. And we type here year and percentage. So before I complete the command here or the instruction, let's just go through this again. This is the instruction to create a ggplot, to create a visualization. The data source is Central Asia data, comma, and then the aesthetics, the 2 axes, I suppose you could say, for our purposes here, is going to be the year along the x-axis and the percentage along the y-axis. We close this, we close these parentheses, and then we close the other parentheses as well. So everything is nicely closed up, just like it would be if you were using HTML, for example, and then we press enter here. Now, it's not very exciting, but under plots, we do have our graph now, or we have the beginnings of our plot. As you can see here, if you move the windows, you can change the size of the plot a little bit. There are advanced packages that allow you to export your plots at a much higher resolution, so don't worry if you think this is not necessarily a particularly great size or great resolution. One of the handy things about R with this is you can actually drag and drop. So if you wanted to drop this into your desktop right now, you could do that like that. Not very exciting, as I said, but it does allow you to see where we're getting started here. So under the x-axis, 2000, 2005, 10, 15, there's our year, and on the y-axis, percentages going up here. So that's a great start. Let's add data points to the ggplot. Now, here's a very important caveat or lesson to learn here. You have to put a plus sign on the original line to, if you're going to add anything, you have to add a plus on the original line. So here's how we would go. I'm going to copy and paste this line. Here's our original plotting line, plus sign, and then now I'm going to add geom point, and this is a scatter plot instruction or command for R, which is going to which is actually going to plot some data properly. And the thing you want to do after that is go to size equals, and in our case we can just put 2. What we're doing is we're telling R the size of the data points. This is easier to see now as soon as we actually run the command. So let's press Command and Enter. What's happened here is it's created a scatter plot of the data that's inside this little data frame, relating to year and percentage, and the geom points are the black dots, obviously, and the size you can see is dictated by the number here. It's somewhat arbitrary. For example, I could change this to 1, and you can see how the data plots have got smaller, and you can really, there's really a great deal of freedom with this about how it works. It really has very few normative limits over how you can represent the data. You can be as creative, as abstract, as ambitious as you like, but make sure it's readable. If you're wanting to make sure it's data that goes into your writing, into your research. So let's maybe add a bit more customization. I'm going to put here, change size and color of data points. This is a nice little customization you can do. I'm going to copy and paste here. Here we've got the original line, calling up the data, the plus sign, again, geom point, and inside these brackets, I'm going to change, let's see, 2.5. Then I put a comma, and inside these brackets, I can put color equals, and then you can type in whatever color you like. And R has some prefigured colors that it recognizes. You can also use extendable packages in R to add, for example, hex codes or a much wider variety of data points. But for us, let's just type in here red and see if R recognizes red. And we press enter, command enter, and you can see the data points are now red. If you want to go back to any of your previous plots, the little arrow here is really useful here for going back to all the different plots that we've done right back to the beginning, and then we can scroll through. When you're working with data sets that are very large and very demanding, be aware that the processing power of your computer might slow down this scrolling. This is an example of where R is really only as powerful as your computer. So if you're dealing with very heavy data sets, scrolling through might be a little time consuming. You may not get such a quick response as we are here. So just keep that in mind. R is really only as good as the computer that you're working it on. So we can also add, as well as data points, we can also add lines. So I'll put here add line, and I'm going to copy our original plot, our original code. And now I'm adding a new line to our graph, to our code, sorry, a line to our graph as well as our code. A plus sign goes at the end of our original line. And then we type here, not geom point, but geom line. And R recognizes that. The help here is quite useful. It gives you a little bit of an insight into what it's offering. GeomPath connects observations in the order which they appear in the data. So geom line, we can do size. Let's just start with 1. That's a basic conservative starting point. And again, just with the data points, we can type here color equals, and maybe we can make our line navy. How about that? Command enter, and we can see our data is now connected up with lines. If you are dealing, if for example you work in statistics, if you happen to be working with data visualization, be aware that there are particular packages and functions where you can change the slope of these curves. It doesn't need to be as angular as this. I'm not going to cover that in this session, but just know that you can change the functions that provide curvature to these particular lines, whether they're smooth, sloped, or angled, as we can see here. And then finally, we are at the final stage now, where we're going to add a title, title and theme. And this really is the final furlong. So we're going to piggyback off our work as we've done before. We're going to paste it here. I'll put a plus line, and I'm going to type labs, which is not short for laboratory, but for labels. And you can see here the little yellow help box is giving you a bit of insight, the kind of variables or the kinds of tags you can put into your instruction to R. Then a little explanation here about the type, the reason for needing labels. I'm going to start here with title. It recognizes that this is an instruction you can put into R. I'll put quote marks here, and I'm going to type out here percentage of internet users in Central Asia, 2000 to 2019. So that's a nice title for us. And then I'll press enter. And there's our title. It doesn't look particularly outstanding. It's not incredibly visually attractive, but as you get more familiar with R, you will find out that there is really a million different ways to customize these charts. You can change the color, you can change the font, you can change the background and the style. I will experiment here just by changing the theme. I'm going to put a plus sign here and show you that, for example, you can change the theme of your plot. If I just type theme at minimal, you don't need to put anything in the brackets here. You're just telling R that we're going to theme this graph, a bit like a WordPress theme. The plus here goes at the end of the line. We add our new function. We're telling R this graph is going to have a minimal theme. Press Command Enter, and you can see that the background is clearer. So it's a little more simple to read. It looks a bit less like it came out of a 90s textbook. That's it for this tutorial, this intro to R. I hope you learned something useful here. This is really the basics to get you started with R. ggplot isn't required. The base R package, the basic RStudio, does have data visualization functions in it, and you don't have to use ggplot. But ggplot is very popular. There's a lot of talk about it on social media. So it is useful to get started with, and it's as you can see, the customization options are really useful. They really help to produce detailed. They help to offer detailed insights on your work. So I'm going to leave it there, and thanks for listening.